In the last video, we talked about the Cartesian coordinate system. And in that video, one of the things we learned was that the solution to a linear equation is a little bit different than the solution to, say, a one-dimensional equation. In this kind of equation, the one-dimensional equation where we just have an x, something like a 3x is equal to 6. Well, the solution to something like that would be that x is equal to 2, and that would go on our number line here at 2, and it would actually be that dot on the number line. Well, what we learned in the last video was that the Cartesian coordinate system takes a second number line and puts it at a 90-degree tilt at the origin, meaning that I've created quadrants in two-dimensional space now. So we need to know a little bit about the nature of the solutions to these two-dimensional equations. Let's suppose we call the horizontal axis A, and let's give the vertical axis the title B. This is different. Normally we'll call them X and Y, but just for now I want to see what happens if we take a look at an equation like this one. This one says 5b minus 3a is equal to 34. So let's take a look at some possible replacement values for a and b. Let's see what happens when we substitute 2 and 8 for a and b, and then let's see what happens when we substitute -1 and 6 also for a and b. Well, when we substitute these values, what we're looking to see is if these coordinates are solutions to this equation. Will they yield a valid statement? So we'll say that 5 times the b value, which would be in this case 8, minus 3 times the a value, which in this case would be, in this first case would be 2, and we're going to set that equal to 34. Does this make a true statement? Well, let's give it a shot. 5 times 8 is 40, minus 3 times 2 is 6. Is that equal to 34? Well, yeah, as long as 40 minus 6 is 34, it in fact does equal 34. So we check out there. What that means is that this statement is made true when we use the coordinates 2 and 8. So let's see what that looks like. Here's our 2, and let's see, 1, 2, 3, 4, 5, 6, 7, 8. So we'll go 2 and 8. We have a point right there. Now, the solutions to an equation in two-dimensional space is, as long as we don't have an exponent on either of these variables, then the solution will be a line. We are doing linear algebra after all. There's a solution to this line, to this equation, that is a line, and what we want to know is, will this point also, -1, 6, so here is -1, and 1, 2, 3, 4, 5, 6, is this point, -1, 6, is that also a solution? We've already verified that this one is. 2, 8 is a solution. Let's see if -1, 6 is. So we're going to do, we need to see if this statement is still true using the point -1, 6. So we'll say 5 times the replacement value of b, which in this case is 6, minus 3 times the replacement value of here, -1. Will that equal, does that equal 34? Let's take a look. 5 times 6 is 30. 3 times 1 is 3. Negative times a positive is a negative is a positive. This isn't looking good, because this says to me 33 is equal to 34, and that's simply not true. So this statement here is false, which means the line that goes through 2.8, so here's 2.8, and that's, I mean not 2.8, 2 comma 8, and that's true. And here's our other one at negative 1, 6. So the line that definitely goes through that point there and is described by this equation will not pass. I mean, maybe that's what the line looks like, I'm not sure. But we know for sure that it does not pass through negative 1, 6. So the solution to a linear equation will be an ordered pair that makes this statement true, and that will be a part of this line. Any other point on this line will make this statement true.